Hello, everyone. Nice to meet you. Sorry, it's in English. I don't know Spanish. I am Gilberto Braglia. I am the head of sales for Move Solutions. I'm here talking about structural health monitoring. So we are a company developing structural health monitoring systems, but I don't want this speech to be so technical, so I'll keep general, and then if you have questions, we can go to more technical level. So basically, what is structural health monitoring? So it's something that is coming in these years, especially across Europe. So basically, during the last century, we built a lot of. Okay, so again, I try again. What is structural health monitoring? So basically, in the last century, we built a lot of structures, every kind of structures from bridges to buildings, monuments, and whatever, believing that it's just enough to build them and to use them without checking them or monitoring them or anything. Actually, what it came out during these last years, during the last tens of years, is that they're like human bodies, and they do need to have someone check on them and do maintenance and do works to understand if it's all okay and to keep them alive for as long as possible, let's say. So now, during these last years, we had kind of a infrastructure crisis. I mean, we had structures and infrastructures with problems. We had a lot of failures and collapses, and we didn't know very well how to approach the problem. I mean, there are some players that do knows how to do that, but it's not that common. So I don't have a chart with me today, but if you look at the failures during the last years, you have hundreds and hundreds of failures per year. Only thinking about bridges. Only about bridges, you have tons of bridges that failed. You have sometimes, hopefully and likely, no injuries, but sometimes we have deaths, and we have very, very, very big problems from a human point of view, and also from an economical point of view, and from a functionality point of view, because when a bridge collapses, you have a lot of problems all around. So back in time, explaining about what we are doing here in Move Solutions. So back in 2016, we were a group of, I would say, kids, a group of guys passionate about electronic engineering and telecommunications, and we did want to work in that kind of area, and so we started to work with the Internet of Things and to work around telecommunication, low power wide area network that are the ones that are used in the Internet of Things. So in the 2017, we had to face a problem. We were requested to develop a new kind of sensors, and a sensor that didn't exist, and we developed it and we released it with the patent in 2018. It was a success. I will explain you what kind of sensor, and then we started to market it and to develop a whole system for structural monitoring. So that's what we do. So the problem, talking about the market, what we had is that we were having a lot of problems in terms of infrastructures and structures, but nobody were actually moving until we had, I'm Italian, the company is from Italy, in Tuscany, and we had a big problem in Italy. I'm sure you remember the Genoa bridge that collapsed with a lot of injuries and deaths and a lot of people homeless and a lot of stuff. And at that point, the country, and together with the country, part of Europe, started to do something. And so in that case, they started to create incentives. They started to launch tenders to do structured monitorings, inspections, maintenance, predictions about what is going to happen about our structures, and let's say a big plan that is now financed from the European Union, and a lot of things. So the roots of the problems is that, as I started to tell you some minutes ago, we believed that the concrete was eternal. So the concrete and some other materials that we used to build our structures. Now I'm talking about bridges, but it's applicable to any kind of structures. I mean buildings, I mean dams, I mean railways, tunnels, and whatever. We believed it was basically ageless. Actually, we didn't consider a lot of things like the pollution, like the stress over that kind of structure that at the beginning was a certain amount of stress, and after 50 years, it was another amount of stress because of more population, more cars, more traffic, and whatever. And so, and at the beginning, we weren't considering actually the durability of the things that we were building because we didn't believe that they were going to actually expire. So what we decided to face with Move Solutions was to create a new kind of structural monitoring system because, let me explain, it did exist other kind of monitoring systems. Usually they were wired, they were static ways to monitor the structures, but it did exist. But what we wanted to do was to develop a new way to monitor structures that had to be low cost, that has to be easy to install, and we wanted also to provide a way to take data in and take out information about the structure. Because there are different kind of systems that basically are up 24 up to 7 days over the week, but you have tons of high frequency data, you don't know what to do with that because there are tons of raw data. So we wanted to easy all of this process. So we developed this new system that is basically a wireless IoT battery-powered sensor system that is both static and dynamic. So what we did is to take out different kinds of sensors, tilt meters, accelerometers, vibrometers, some new sensors like the one that I showed you before that was patent that is called DEC, some unique kind of sensors that are actually battery powered. The battery lasts for years, and they communicate through a wireless protocol that is called LoRaWAN, and they basically, sorry everyone for the problem. So basically what we did develop is a full system, as I told you, made of sensors of different kinds. So we have tilt meters, accelerometers, vibrometers, and whatever. We have wireless loggers to connect different kind of sensors, like for crack monitoring, for geotechnical monitoring, and whatever. So super brief how the system works. So basically, you have to mount different sensors in even a large area of kilometers area. Every sensor is autonomous with a battery inside that lasts for years, and the battery transmits to a gateway. The gateway is a central unit that usually is a single one, but it can be even more if the area is very wide. It receives all the data from the sensors, and with an internet connection, it uploads everything to the cloud. The connection usually is made by a mobile card, but it can be made, however you prefer. And then you have a platform. We developed this platform that is a super user-friendly platform where you can access all of your live data. You can also see all the data history, and you can apply some specific algorithms that we provide to understand your structure. So we provide some specific algorithms for, for railways, some specific for tunnels, some specific for bridge model analysis, and whatever. You can also use your interface if you have other kind of platform, for example, for BIM managing or digital twins or whatever. You can connect your platform to our data with different kind of technology and export all the data to your, and basically plotted on your platform, both the raw data and the results of the tools and the algorithms that we're talking about. So basically, our system is made of three main bricks that are first the hardware, the wireless sensors in place. So all the sensors that I were talking and the gateway. The sensors are many different kinds of sensors. I don't want to explain you sensor by sensor now. Then we have the software as a service where you can see all the data. It's intended like an interface, and it's very studied to be usable from everyone, from like an easy access just to check if everything is okay or not, to engineers to understand very, very deeply the structure. And then we have all the data analysis and calculation part, where you can deeply understand the structure and where you can enable some advanced tool that we provide. So that's how the system is made. Talking about the platform is a cloud-based platform that we provide, so you can access from every device that you just need to be connected to the internet. You can from it set up your sensors remotely. So set up timing, thresholds, alarms, resolution, whatever. See if everything is online, or if you have any kind of problem. You can see all the story. You can compare data to other data, and you can also, of course, apply all the tools that I was talking. To make you some example, we have some tools specific for the track geometry for railways. So you know that for a railway must be into some standards in terms of track geometry. There is the cant and twist value that is basically how the railways moves over its length. Or, for example, you have the vertical displacement over its length. So you have to stay into certain parameters to be sure the train that passes don't have problems, basically. It's all automated into the platform. Same things, for example, for buildings. We provide some sensors that are called vibrometers, where they can check if the vibrations on the structure are over some levels of tolerance on the standards. So all tools that we provide of different level of specificity to understand better your structure. So talking about the different kind of monitoring, we divide the kind of monitoring into three areas: static monitoring, dynamic monitoring, and geotechnical and environmental monitoring, that are very different between each other. And one of our pros is that we provide the full suite of monitoring. So static monitoring is the kind of monitoring that is long-term, is made by, for example, as I told you before, tilt meters, crack meters, load cells, whatever, tilt meter chains, and you usually check some very easy to understand values, and you check it over time. So you want a data every 5 minutes, 10 minutes, 3 hours, and you want to see if this wall, for example, tilts and moves over, yes, 2 days, but even over 6 years. You want to see if everything is steady or not. Even if you have a crack, you want to see if it opens and closes. Even if you have a point with a certain pressure, you want to see if this pressure is steady or if it changes. So this is the static monitoring. Then you have the dynamic monitoring. This is more tricky. It's about vibrations, accelerations, and frequencies. So that's where Move started. We started from the dynamic, and then we expanded into static and geotechnical. So basically, the dynamic monitoring can be done from triggered events. I mean, I can place here a sensor, and I can see if something hits the ground around here, I can see exactly how everything moved after this hit. That is something that we are doing with wireless sensors. That is something pretty unique on the market, because usually when you're wireless, you do the static part. We do the dynamic as well, because for us is the main monitoring part. So you can have the part, you can check the trigger part, but even more important, we can understand the dynamic fingerprint of the structure. For example, let's imagine a building or a bridge. You can mount several accelerometers on it, and you can start to getting the white noise. You can start to understand what are the natural frequencies of vibration of the structure. And then there are some tools on our platform, on our servers, that take out the frequencies and can understand how the fingerprint changes over time. That is very, very important to understand if the DNA of the structure itself is changing, and then you can see if it's actually aging and how. And it's very important. And to close the part, we have the geotechnical and environmental that is important to relate to the other two that I explained you. I mean, if you go to check the weather around the structure, for example, how is the temperature, how is the humidity, how is the water level, how is the water percentage on the ground, and whatever, those are a lot of environmental values that are very, very useful to be related to the dynamic and the static part, to understand then which part of the movement that I saw was due to the environment, and which part is due to the aging and the consumption of the structure itself. So these are the ways we approach the monitoring problems. I have now some examples to show you. For example, this is an example of static monitoring, where we had this big building under reconstruction. Basically, there are some civil works over the building, as you can see. And they mounted a lot of telemeters over the structure, building like a grid to understand how every point of the structure deflected over time during the works. And of course it moved, because everything during this kind of works moves. So, and to keep everything under some threshold to be sure that there are no problems in what we are doing in terms of working. This is, if you remember, a couple of years ago, there was a big explosion in Beirut. There was like a deposit that exploded, a grain deposit, I think, with, of course, a big disaster. And some big silos stayed up. So those are the big silos. So they used our tilt meters. Actually, it was a super easy installation. I think it was just 4 tilt meters placed in a grid in the center of this, let's call it, wall. And to check the stability, because they decided to keep it up, but they wasn't sure that they actually can stay up. So after some months of monitoring, they saw a starting of moving of these walls, and in the end, it fell down, actually. Now, this fell down, but they noticed that 10 days in advance, and they were able to put everything in safe, and nobody was injured. So this was an example of static. They are telling me I have to close, so I'm super quick. 1 minute, I close. So this is an example of dynamic monitoring. This is an hospital after the earthquake in Turkey, for example. So here, there was placed several accelerometers to be sure. This was a version of dynamic monitoring made for events. Be sure that there were no failures basically, because of course they were still using the hospital again. The next one is a iron tunnel with some construction works next to it, and they did the modal characterization, so the fingerprint that I was talking before of the structure, and they checked that it stays the same during the works. Of course, you have every time effects when you start to work around every kind of structure. And just to finish, this is an example of environmental monitoring. This is an embankment down of a railway when a train passed, and basically, of course, the train waits a lot, and you see, and they were afraid that the ground starts to go lowered, basically, and so they used a lot of telemeters on a pole planted on the ground to be able to understand how the underground is moving, and they overlay a lot of data to be sure that it's still safe for the train to pass. So to conclude, what we did a system that is cost-effective to do the early detection on every kind of issues and to understand in advance if something happens. Not only, but also to be mounted at the beginning and be able to understand how the structure ages itself, and to be able to understand if I have to do something on the structure before it's too late or too expensive, basically. That's the thing. Thank you.